If we wanted to use the basic three trig ratios, sine, cos, and tan, beyond 90 degrees, then we need to know what the general definition of an angle is and how to convert any angle into an acute angle, also known as a base or a reference angle. So this will make more sense tomorrow when we take the three trig ratios beyond 90 degrees. But for now, let's just understand what the angle is that we're referring to. So here we have the Cartesian plane. And if we had to create some line from the center of the Cartesian plane, so from point O to some point P, now I'm going to just choose any point P here, and we want to create a line from point P to the origin. And the angle that we are interested in is the angle that this line makes with the positive x-axis. So this is the positive x-axis here, and the angle that we're talking about is this angle here. So we can call this angle theta for now. And the important thing to note is that when we're working with trig, when we measure the angle from the positive x-axis, anti-clockwise is positive, and if we'd had to rotate this point P in the opposite direction, it would be, if we're talking about clockwise direction, then it would be negative theta. Now I can rotate this point anywhere, right, as long as it's the same distance, and as point P rotates around, it will create a different angle, but the angle is always measured from the positive x-axis. So if I move point P over here, then the angle that we're now measuring is from the positive x-axis all the way to my new line over here. So that is what theta represents as the angle. Now, as we've just seen, theta is now, or line OP has moved from one side of the Cartesian plane to the other, and so we call the Cartesian plane by the different quadrants depending on where the line is. So for instance, if it's in the first quadrant, then it is over here. This is the first quadrant, and the first quadrant goes from 0 because we start at the positive x-axis, and it goes up to 90 degrees at the top. Beyond that, we move into the second quadrant, and the second quadrant runs from 90 to 180 degrees. And the third quadrant, that will run from 180 degrees to 270 degrees. And finally, the fourth quadrant, it will run from 270 degrees back to 360 degrees. And for angles that go beyond 360 degrees, we would just continue moving in either a clockwise or anti-clockwise direction, depending on whether the value for theta is positive or negative. So again, positive values for theta, we go anti-clockwise, and negative values for theta, we work clockwise. So it's different to bearings, where bearings would work in the opposite direction, and bearings are always measured from north rather than from the positive x-axis. Now, one other thing to note is, since we have now learned radians, we need to also remember that these angles can also be seen in radians. So 0 is 0 radians, 90 degrees could be pi on 2 radians, 180 degrees would be pi, 270 could be 2 pi on 3, and 360 degrees would be 2 pi. And if we go beyond 2 pi, then we're just doing a full rotation and continuing in that direction. Now, what we need to know how to do, more importantly, is how to convert an angle that is greater than 90 degrees. So if we have line OP extending beyond the first quadrant, the angle it creates is greater than 90 degrees. And what we need to do is we need to know how to change this into an acute or a base or a reference angle. Now, the reference angle is always measured from the x-axis, so that's the entire x-axis that we are now talking about. So, for instance, if we are talking about a line OP extending up over here to point P in the second quadrant, we want to convert that angle theta into an acute angle, and the acute angle that we will use will be measured from the x-axis, right? So from this part here up to line OP, and this would be my reference angle for theta. Let's just look at a few examples of a few angles, and hopefully they'll help us get an idea of what we are talking about. So here we are asked to draw a diagram showing the quadrant in which the line or the rotating line OP lies for each of the following angles, and in each case we want to find the acute angle that this line makes with the x-axis. Okay, so the original angle is going to be measured from the positive x-axis, and the acute angle will be measured from any part of the x-axis, the shortest distance to the line. So the first thing we need to do is look at the angle, and the first one says 240 degrees. And we need to work out in which quadrant this lies. So it's greater than 180 but less than 270. So that means that OP lies in the third quadrant somewhere over here. So this could be the point OP. Now, the original angle is measured from the positive x direction, or positive x-axis. So from here all the way around, this would be 240 degrees because the angle is positive, so we move in an anti-clockwise direction. So to convert this into an angle that is acute, we will measure the shortest distance from the x-axis to the line. That happens to be the negative x-axis, and it will be from here down here. And we want to know what the value of this angle is. So intuitively, if it takes us 180 degrees to get from here to here, that's 180 degrees of my 240, then there must be 60 degrees left over to get from the negative x-axis to the line. And so the acute angle, 240 degrees, can be rewritten as 60 degrees. So our acute angle here is equal to 60 degrees. Right, for question B, this time we have negative 70 degrees. So what negative 70 degrees is means that we are measuring from the positive x-axis and we're going in a clockwise direction this time. And if we go only 70 degrees, we will stay in the fourth quadrant. So we would be somewhere over here, okay? And the angle theta that we are measuring is this angle here. It is negative 70 degrees because it's going in a clockwise direction. And once again, we will measure from the x-axis, any part of the x-axis, the shortest distance from the x-axis to the line. So not this distance here, because that is the y-axis. So it is, again, we're going to be measuring from the positive axis. And so the acute angle here is just 70 degrees. Right, the same as the original angle. All right, question C says 490 degrees. So we want to go 490 degrees. That's more than 360 degrees. And so what this means is we're doing one full revolution, and then we are continuing for another 130 degrees beyond that. So in other words, we are doing one full revolution of 360 degrees, and then we are rotating another 130 degrees beyond that to create our line OP. So the full rotation would have been 490 degrees. And so the acute angle we will measure from the positive x-axis, so that will be from here up to there. So if we've done a full revolution, then we're at 360 degrees, and because we had to extend to 490, then this angle here is 130 degrees, which means that this angle here, right, if this is 180 degrees, then this angle here must be 50 degrees. So our acute angle here is 50 degrees. So our final question is 2 pi on 3. So 2 pi on 3 is in radians. So it's 2/3 of pi. Pi is over here, it's about, well, it is 180 degrees, and we're going 2/3 of the way. So it must be some distance here. This is our angle, 2 pi on 3. And we want to measure the shortest distance from any part of the x-axis up to the line. So that's this distance over here. And if the full distance from here to here is pi, then we take away that 2/3 pi, and that leaves us with the acute angle, which is just going to be pi over 3. So 1/3 pi. So to summarize and to make things more easier, we can think in general when we're measuring or changing angles. If the angle is in the first quadrant, the value stays the same as theta. If the angle had to extend beyond into the second quadrant and we wanted to calculate this angle here, the total distance from the positive x-axis all the way to the other axis is 180 degrees, and so if we want to calculate the angle in the second quadrant, what we're doing is we're taking 180 degrees and we're subtracting the value of theta. Now if we extend into the third quadrant and we wanted to calculate the angle here, so the angle here is then this angle here. So what we're doing is we're taking the full angle, which goes all the way from the positive x-axis all the way around through 180 degrees to the line. And if we want to calculate that distance, then what we're doing is we're taking theta and we're subtracting 180 degrees to give us that angle there. And finally, if we extend beyond into the fourth quadrant here, then the angle we're interested in is here. And what we're doing here is we're taking 360 degrees and we're subtracting the value for theta.